For this video, we're finding the area of the region bound by y equals square root of x, the x-axis, and the line y equals x minus 2. And it was very specific. It said the area in the first quadrant. So I'm outlining that area now. Okay, so to find this area, the first thing I do is actually look at this and say, is my more positive function always the same? If I draw the lines like this, and the answer is yes. It's always touching, the top of each line segment is always touching the square root of x. Is my less positive function always the same? And if you look at the bottom of each line, what each one is touching, right here it's touching the x-axis, but starting right here, it touches the line y equals x minus 2. So if I was going to do this with respect to x and add up the line segments from here all the way to out here, I would actually have to do that with two integrals. So that's the first way we're going to approach this problem. So I'm going to integrate, and for this first integral, I'm going to start at 0, which is where y equals the square root of x starts, and I'm going to go all the way until y equals x minus 2 touches the x-axis. And to find that, I want to know when is x minus 2 equal to 0. And that, of course, is at x equals 2. So my first integral is going to stop at 2. For that region, which is this region right here, my more positive function is the square root of x, and my less positive function is y equals 0. So I would be integrating the square root of x minus 0 with respect to x from 0 to 2. And of course the square root of x minus 0 is just the square root of x. But I'm going to add to that the area of this region, and that starts at x equals 2. So I'll start integrating at x equals 2. And I have to go all the way until these two lines intersect, the square root of x and y equals x minus 2. Now you can solve that by hand or with the calculator, but the x value where that occurs is x equals 4. So I'm going to integrate from 2 to 4, and the more positive function is still the square root of x, and I'm going to subtract the less positive function, which is x minus 2. When I distribute the negative, it becomes minus x plus 2, and it's with respect to x. When I add these two integrals together, I'm adding this area with that area, and I get the area of the entire region. Another way to do the same problem would be to think about this. What if it was with respect to y? What if all our little rectangles that we were adding up, if we were doing a Riemann sum, or we have infinitely many rectangles that are infinitely small in width, which is what we have here, were sideways? So when things are left to right, the more positive side is the right-hand side. This is where the positive numbers are. If you look at each one of the line segments I drew, the right-hand side is always hitting the same function here. The left-hand side is always hitting the same function. So if I actually choose to look at it this way, I can do this with one integral. So I'm going to integrate, and the more positive side will be this one, the less positive one will be that one. So what I have to do is actually think about, since the lines are turned and we're adding up little itty-bitty rectangles from here up to this height here, everything is with respect to y. So this is a dy problem. So if this is dy, that means our limits of integration are y values. And I know that I can actually start my integrating as soon as the figure begins, which is the x-axis, which is y equals 0, so that will be the lower limit of integration. The upper limit of integration will be the y value where these two intersect. Now I knew the x value was 4. If I want to find the y value, I just need to look at my square root function right here, and what is the value of that when x equals 4? Well, I know y equals the square root of x. If x equals 4, then y equals 2. So 2 is the upper limit of integration. The next thing I look at is the right-hand side. My more positive function is the line. And my line's equation is y equals x minus 2, but I need this to be with respect to y, so I'm going to solve for the x here. So I'll add 2 to each side. So y plus 2 equals x. So the first function, the more positive function, will be y plus 2. And I'm going to subtract from that the less positive function, which is the square root of x, except it also needs to be changed. We're going to solve for x. So x equals y squared. We squared both sides. So it's y plus 2 minus y squared. And both of these integrals, this integral and the sum of these two, would give you the same answer because they represent the area of the same region. They're just done differently.